Okay, so I think by now you might have purchased the readings and all. We have chapter number 1 to 9 that we have to do from the book Sitzetter and Hammond. और उसका जो first chapter है वो है introduction. So सारे basic चीजें जो हैं आपको explain किए हुए हैं. So we will also start off with that only. So जो चीजें important हैं, inequalities, intervals, basic real number stuff, set, proofs and implication, वो सारी चीजें हम लोग cover करेंगे. ठीक है? तो आई थिंक वी कैन स्टार्ट एंड नो वरीज स्टार्टिंग में लगता है कि एकदम से इतना कुछ करा दिया है एंड कॉलेज में बहुत सारी चीजें चल रही होती हैं. सो जस्ट बी रेगुलर, कीप सॉल्विंग योर प्रॉब्लम्स बोथ फॉर स्टैट्स एंड मैथ्स, सो एवरीथिंग विल बी फाइन. चलो लेट्स स्टार्ट देन. हम लोग जो है we will start off with the basics, which is first we'll try and understand the basic things regarding real numbers. ठीक है, रियल नंबर सिस्टम क्या क्या होता है. तो you might know all of this already, but just for the sake of completion, I don't want to assume any prior information and I'll teach you like you don't know anything. Okay, चलो जी. तो सबसे पहले रियल नंबर सिस्टम. तो रियल नंबर सिस्टम में हम लोग क्या पढ़ते हैं कि किस किस तरीके के नंबर्स होते हैं. सबसे पहली चीज जो होती है, सबसे पहला कॉन्सेप्ट है व्हाट इज नेचुरल नंबर्स. सो नेचुरल नंबर्स क्या होते हैं, नाम ही है नेचुरल. सो लाइक एवरीडे थिंग्स या एवरीडे नंबर्स एक तरीके से इनको बोल सकते हैं. ठीक है, सो नेचुरल नंबर्स क्या होते हैं, ऑल द नंबर्स स्टार्टिंग फ्रॉम 1 2 3 एंड सो ऑन, इनको बोलते हैं नेचुरल नंबर्स. ठीक है, सो second thing that we have is whole numbers. What is whole numbers? whole numbers क्या होते हैं, बहुत सारी चीजें हैं. जैसे आप चीजों नेचुरल नंबर्स को ऐड करोगे तो आपको नेचुरल नंबर ही मिलेगा. नेचुरल नंबर को मल्टीप्लाई करोगे, कोई भी दो नेचुरल नंबर को यू मल्टीप्लाई, इट विल गिव यू अ नेचुरल नंबर ओनली. बट इफ यू सब्ट्रैक्ट टू नेचुरल नंबर्स देन you know you need not get a natural number. Yeah, if you subtract 2 minus 2, there is a need for having 0, there's a need for having negative numbers. So that is where, that is the logic that we are following. और उस सीक्वेंस में हमें अलग अलग नए नए नंबर्स को डिफाइन करने की जरूरत है. ठीक है, सो होल नंबर्स क्या होते हैं, 0 along with all the natural numbers. तो आपके होल नंबर्स क्या होंगे, 0 1 2 एंड सो ऑन. ठीक है जी. Guys, just want to clarify once, you are okay with Hindi and English both? Or
Yes, ma'am. I'm okay with both the languages.
Ma'am, I'm comfortable with English.
okay, you're not able to understand Hindi at all?
No, ma'am, I'm from Kerala, so we
Okay.
don't speak Hindi.
Okay, so I'll try to restrict myself to English, and in the middle also I'll try to like mix things up a bit, but I'll keep that in mind. Okay.
Okay, ma'am.
All right. So the next thing that we have is integers. Now, what are integers? So integers are basically numbers which is 0. Then we have plus minus 1. We have plus minus 2. We have plus minus 3 and so on. Okay, integers. And you can also plot these integers on a number line. Okay, what is a number line? It's basically a line, and at the center you have 0, and then on both sides you have positive and negative numbers. So we have 1, we have 2, we have 3. Similarly, at the same distance, we have minus 1, minus 2, and minus 3. So this is called a number line. So these are integers, both positive, negatives, and 0 included. All right. What is the next number that we have? We have rational numbers. Now, what is a rational number? Rational number क्या होते हैं? So any numbers that can be written in the form of A divided by B, where A and B, they are both integers. So if you are able to write any number in this format, in this ratio A by B, where A is also an integer and B is also an integer, you call it a rational number. Okay. For example, you can write 1 by 2, you can write 11 by 70, you can write 0, you can write 0 as 0 by 1, right? You can write 1 as 1 by 1. You can write minus 19 by 1. So all these are called rational numbers, right? So by that, following that logic, every whole number is a rational number. Every natural number is also a rational number, right? So any number which cannot be put up in this form is not a rational number, okay? So what do we call them? So there must be some numbers which cannot be put in this form, right? So they are called irrational numbers. Irrational numbers. Now, what is an irrational number? They can, so these are the numbers which cannot be represented in the form of A divided by B. So for example, can you give me some examples of irrational numbers? So like root 2 is an irrational number. Root 3, it's an irrational number. You must have heard of pi, right? Pi is also an irrational number, right? You cannot write it in the form of A by B. Now you might be thinking that हम तो pi को 22/7 लिखते हैं. We write pi as 22/7. But this is just an approximate value of pi. This is not the actual value of y. So whenever you used to do calculation, you used to use this so that you can do the calculation simply. But this is not equal to pi. So pi is not equal to 22/7. Pi is an irrational number whose approximate value is 22/7. It's not the actual value. Okay. So any number which cannot be put in this form p by q is an irrational number. So now we have two sorts of things. First, rational number and irrational number, right? So if I want to classify rational numbers, what I can do is, every rational number can be thought in terms of the following. First, either it's a finite decimal fraction, either it's a decimal fraction which is finite. That means it's a number जिसके जो decimal हैं they stop. It's finite. So like there are 4 decimal, there are 5 decimal, there are 2 decimal, right? So what could be the possible example of this? It could be like 3.142. It could be 1.1. It could be 1.0. It could be 2.3. And why are they rational? Because what you can do is you can write it like 3142 divided by 1000, right? So this is also an integer and this is also an integer. And we said if you can write something in the form of p by q, it's a rational number. So this is a rational number. Same argument you can apply anywhere. So anywhere your decimal is finite, it's a rational number. Okay. What is the second set of like the second category that we can find among rational numbers? It is, so your decimal can be infinite decimal fractions, but they should be periodic. What does that mean? Uska kya matlab hai? That means, so even if your decimal is not ending, even if my decimal is continuously going on, but there is a pattern which it is following, right? So let's say we have a number which is 0.3333333. This 3 keeps going on, right? So what do you think? What kind of a number is this? If I'm able to put this number in the form of p by q, where p is also an integer, q is also an integer, then I can say that this is a rational number. So what is this? Can you tell me how should I write it? What can I write it like in terms of fractions? What can I do? So do you remember doing some problems wherein you used to multiply it by something? You remember that? So what I can do is, I can put it equal to x. So x is 0.33333. What pattern I'm seeing? I can see that this is 3. This 3 is getting repeated. So whichever pattern is getting repeated, we can put a bar over there, right? I can put a bar here. So x is 0.3 bar. What you do is you just multiply this particular x with a 10, 100, 1000, 10,000, so that this pattern can be replicated again. So if I multiply this by 10, so I'll get 10x here. And here, what will I be getting? I will be getting 3.33333, right? And this 3 will keep going on. Yes or no?
Yes, ma'am.
Now what I can do, I can write it like 10x equals to 3.3 bar. So you see this and this, they are exactly the same after decimal. Now what you can do is you can subtract these two. This and this you can subtract. So if you subtract, what do you get? 10x minus x. What will you be getting? I will be getting 9x. And if I subtract this 3.33333 from 0.33333, what will I be getting? I'll be getting 3, right?
Yes.
So you have 9x equals to 3. So what is x now? 3 divided by 9, which is what? X is equals to 1 by 3. So what we have done is we have written x, which was earlier this. And it is written in the form of a divided by b, where a is 1, which is an integer, and b is also 1, which is an integer, right? So any decimal which repeats, kind of it brings us to the conclusion that it can be written in this format, right? Similar logic, say, following the same logic. Let's say if I give you something like this. So, I can give you 10.835835. So you just have to recognize what is the pattern which is being followed, right? So here what is happening? 835, 835, 835. This is being repeated again and again. So you can just say that this is x. Now what will you multiply x by? X को आप किससे multiply करोगे?
1000.
1000 you'll multiply. So you will get 1000x. So when you multiply it by 1000, what are you going to get? You will get 10835.835. So this pattern will keep again repeating. Now you just follow the same procedure. You subtract. You are going to get 999x equals to, what will you be left here? So this and this, they will cancel out completely. And you will just be left with 10 here. So you will be subtracting that. So 10825 you will have here. 10825. So what is x here now? 10825 divided by 999. So what do we see? Anywhere this decimal is repeating, it's a periodic decimal. It is following a pattern. You can write it in the form of p by q. So what we follow from this is either our decimal is finite, even in that case, it's a rational number. And even if it's an infinite decimal, but it is repeating, it is rational number. So these are the two categories that we have. Okay. So either decimal stops or either decimal doesn't stop. If decimal doesn't stop, if there is a pattern, it's a rational number. Now, what is the other category? What is the only possibility which is left? So if your decimal doesn't end also, it's infinite and there is no pattern also. So now what will those numbers be? Those numbers will be irrational number, right? So what is an irrational number? Anything which is an infinite decimal which is non-repeating. non-periodic, or which is non-repeating. Okay, so these kind of numbers are called irrational number. So there is no pattern also, and these decimal have no pattern attached to it. They are infinite also, they're non-repeating also. That is why you see, right? Whenever we talk about pi, it's 3.14 something, 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 something. It'll keep going on and there is no pattern also, right? That is why pi is an irrational number. Okay. Is that all right?
Yes, ma'am.
Right. So now we have two sorts of numbers. First, rational number and irrational number. So now I want to club them together and say what kind of numbers we will get if we'll combine both rational and irrational. So we get real numbers. So what is a real number? So if I have to technically define a real number, it is nothing but it is an arbitrary, infinite, decimal fraction. Meaning what? So every real number is basically an infinite decimal fraction, right? So now how does it cover both real and how does it cover both rational and irrational number? उसमें rational और irrational number दोनों कैसे आते हैं real number में? So if I have to define real numbers, there'll be something like this. So real number x I'm saying it's a real number. So it will be either positive or negative m dot alpha 1, alpha 2, alpha 3. So what is m? M is basically any integer. It could be anything, 0, 1, 2, 3, 4, up to 9, right? Or basically not up to 9, it could be anything. It could be any integer, right? Now what is alpha 1, alpha 2, alpha 3, up to alpha n? So these are basically, so what is this? This is basically an infinite sequence, yeah, or you can say infinite series of digits. So, you know, alpha 1, alpha 2, alpha 3, these can take value from what? From 0 to 9. So alpha 1 can take value 0, 1, 2, 3, up to 9. Alpha 2 can also do the same. Alpha 3 can also do the same. Similarly, this will keep going on. Now, how does it include both rational and irrational? Rational numbers, we said, either they are finite decimal. So let's say if I have something like this, 3.2. So here in this case, my m is 3, my alpha 1 is 2. And what is my alpha 2? What is my alpha 3? 0, 0, 0, 0. So this infinite sequence is all of zeros, right? Similarly, if it's something like this, like in the example that we saw, what is this? My m is 0 here, alpha 1 is 3, alpha 2 is 3, alpha 3 is 3, alpha 4 is 3, and this will keep repeating, right? Now, how does it cover irrational number? Whatever numbers that we have, which are non-repeating, alpha 1, alpha 2, alpha 3 can take those appropriate values. So this particular definition covers both rational and irrational. That is why we say that real number is basically a collection of both rational and irrational numbers. Is that all right? So do we see the logic why this is happening? Fine. Any doubts so far?
No, ma'am.
Okay, perfect. All right. Okay. Chalo ji. Now what you can do is you can add real numbers, you can subtract real numbers, you can divide, and you can multiply. So all the basic 4 arithmetic operations that we have, you can perform on real numbers, except for a few things. What are those few things? So whenever you add, subtract, multiply, or divide any two real numbers, you are going to get a real number only, right? So except for a few things, which is the only exception is when you divide a real number by 0. that operation is not defined. That is not infinity. It's just that we don't know what that is, right? So the only exception is we cannot divide by 0. So, you do anything, a by 0 is not defined. So we don't know what this is actually, right? A by 0 is not defined for any real number a. So a could be taking any value, any real number value, and you divide it by 0. This operation is not defined. Okay? This is the only exception that we have. All right. So now let's say if I ask you a question, which is for which real numbers x is 3 divided by x minus 4 is defined. If I ask you this question, then what will be your answer? So my question is, what all possible x values you can take so that this particular expression is defined? It's just that it should not be not defined. So what?
Ma'am, it should be more than 4.
Okay. So let's say if I take x value is 5, so we get 3 divided by 5 minus 4, which is 3. So this is a valid real number, right? So you can take anything which is greater than 4. Okay, that is fine. Can
All
we?
real numbers except 4.
Very nice. So can we also take values which are less than 4? So like x is minus 1. Can I take that?
Yes, ma'am.
Right? तो मैं 4 से नीचे वाली values भी ले सकती हूँ, right? Because this will give me 3 divided by minus 5, which is minus 3 by 5. This is a real number, right? So I can take both x values which are greater than 4 and less than 4 also. Only with one exception, which is I can't take x value as 4 because in that case it will become 3 by 0 and that is not defined, right? So what you can write it like, so real numbers को आप इस तरीके से भी represent कर सकते हो. You can represent real numbers with r. So what you can say is your numbers for which it is defined is r, and from r you don't want what? A number 4. So you can write it like this. Okay, that x belongs to this. So this is a symbol which means belongs to. X can take these values. Okay. X belongs to real number except for a number 4. So you can write it like this. Or you can write it like this. X is greater than 4 or x is less than 4. You can write it like this also. Or you can write it like this also, that x belongs to 4 to infinity union minus infinity to 4. You understand this? So this is basically an interval. This is also an interval. We will talk about intervals in some time. So don't worry about all these terminologies. You will understand all of this in some time. Okay? So this is an interval. This is an open interval. So whenever you have an open interval, whenever you have these brackets, that means this element is not included. Whenever you have these brackets, that means this is not included. This is not included. And this is the symbol infinity, which means a very large number. Okay. So you can write it like these three in these three manners you can write. Okay. This is fine.
Yes, ma'am.
Okay. So this was our bit regarding numbers. So we have understood what is a natural number, whole number, rational number, irrational number, real number, and what operation is not defined. So now, while doing this, we figured out we are using the concept of intervals. So let's just dwell a little bit on intervals. So what is an interval? Okay. So अब थोड़ा सा intervals को समझते हैं. ठीक है? Intervals क्या होते हैं अभी? So all these things that you are learning, somewhere or the other, you might have done it here and there, but these will keep coming again and again. So you should be very strong on these basics. Okay, so we want to understand what is an interval. So intervals. What are intervals? Okay. So how do I define interval? What is an interval? So, if you have two numbers, if you have A and B, if A and B are two numbers, so if A and B are two numbers on the number line, so we saw the number line earlier, right? So if A and B are any two numbers on that number line, we call the set of all numbers that lie between A and B, we call it an interval. So if I give you two numbers, so whatever numbers can be there in the middle of those two numbers, whatever is the set of all those numbers, I call it an interval. तो जो दो नंबर्स है मेरे पास A और B, और उन A और B के बीच में जितने भी नंबर्स हैं, अगर मैं उनके सेट को एक साथ लिखूं तो वो क्या होगा? That will be an interval. So if I take all the numbers which are lying between A and B, and if I take a set of all those numbers, that will be called an interval. Okay. So suppose whenever A is less than B, we can have four different type of intervals. So we are just assuming that number A is less than B, so that we know what is the starting point and what is the ending point, which one is the bigger number, right? So if A is less than B, we can have four different types of intervals. We can have four types of intervals. What are those intervals? Let me write it. Okay, so first is we can have an interval which is like this. So A, B, because A is smaller, so we are writing A first and then B. Okay, so an interval like this. What do we call it? This is called an open interval. From A to B. And what does this mean? This means all those values which are lying between A and B, and they do not include A and they do not include B. So in this interval, A and B are not included. So as an example, I can write it like this. So let's say my A is 1 and B is 4. So what is an interval 1 to 4? It means all these x values which are between 4 and 1. So you neither include 1 nor you include 4. Is that all right?
Yes, ma'am.
So whenever you use these brackets, na, तीन तरीके की brackets होती हैं, right? First is this, second is this, and then this is this. So square bracket, round bracket, and curly bracket. ठीक है? Curly bracket, this is a curly bracket. We use it to represent sets, right? This we use to represent something which we will come up just now, which is called a closed interval, and this is used to represent open interval. Okay. All right. So what is the second kind of interval that we can have? So we can have something like this. Closed interval A to B. So we can write it like this also. What does this mean? This means that it is a closed interval from A to B. And what does this mean? This includes all possible values of x which are between A and B, and they also include A and also include B. So these numbers, so if I would have written something like this, that would have included 1 and 4 as well. So closed interval mein, whatever boundary points you have, they are included. Okay. So that is included here. So that is a closed interval. What could be the third possibility? You can have closed only on one side like this, or you can have closed on the left side. Okay. So these are other two possibilities that you have. So you can have something like this. What does this mean? This means this is called half open. This is called half open. So this name actually comes from here. So whatever is written first, that name will come. So this is open and this is half open. And if I write it like this, something like this. So because in the beginning we had a closed interval, so we will call it half closed. Okay. So the first one is half open, the second one is half closed. Actually, these names are not very common. You will not be using these names, but you should know. Okay. So what does this mean? All possible values of x which include b and don't include a. What does this include? All possible values of x which include a and not b. So anything between including a, not including b. So these are 4 different type of intervals that you can encounter while doing any sort of problems. Okay. And all these intervals, because you have, boundaries. So like here you had 1 and 4. There is a boundary, like from 1 to 4, from 5 to 10, from -2 to -3, right? From -3 to -2. -3 is a smaller number, right? So all these intervals are called bounded intervals because they are bounded. So all the above intervals are called bounded intervals because there is both an upper bound and a lower bound as well. So all the above intervals are called bounded intervals because there is a lower bound and upper bound because of the presence of lower and upper bound. So if there are bounded intervals, then there must be something which is unbounded, right? You're not bounded. So yes, we do have that possibility. So we can have unbounded set of numbers. So what does that mean? How do we represent that? So, if I write something like this, that, a to infinity, what does that mean? So whenever I'm writing infinity, what does that mean? This means that all numbers x such that x is greater than, and because it's a closed interval, will I include a or not? I will. So we will have something like this. So all possible values of x which are greater than a can be written in the interval form like this. So your x can take any value. It can go till infinity. So we can write it like this. So, there earlier we saw here, we were writing x greater than 4. So how were we writing it? So 4 till infinity. And because 4 was not included, we had an open interval. Okay. That is what we were doing. So one thing, why are we keeping it open at infinity? Why are we not doing this? Why do you think we are only keeping it open and not closed at infinity? Infinity simply means a very large number, right? So if I put a closed interval there, what would that mean? That I am including infinity, but I don't know what infinity is, right? This big number could be 1 crores, 10 crores, 100 crores, 1000 crores, 10,000 crores. There is no limit. I actually don't know what this infinity is, right? I don't have an exact figure for it. So that is why I'm keeping it open, that we don't know what infinity is. All we are trying to say here is it can be a very big number. That's all. That is why we are keeping it open and not closed. So this is a convention, okay? Like this is the convention that we follow and this is how we write it. Similarly, let's say if I write something like this, that, okay, minus infinity to b. If I'm writing something like this, what does that mean? What all numbers I'm talking about? All numbers x such that what happens? What should I write? So what
X
value?
less than B.
Ma'am, greater than minus infinity and less than b.
Very nice. So x is basically less than b and greater than minus infinity. You can write it like this. But अब ये imagine करो कि अगर मैंने ये part नहीं लिखा, तो क्या ये चीज ऑलरेडी अंडरस्टूड थी कि x कितनी भी छोटी वैल्यू ले सकता है? इट कैन टेक एनी वैल्यू विच इज स्मॉलर देन दिस, राइट?
Yes, ma'am.
So it was naturally assumed. इसीलिए we do not write that specifically, saying this much is enough, but we mean that only, that it's from minus infinity to b. Okay. And because here we have an open interval, so we are not including b. We just have x less than b. b is not included. Okay. So this is how we can write it. All right. And this is simply a notation. So minus infinity is a notation. Infinity is a notation. It's not actually a number. It's just an idea that a number can be so big on the positive side, or it can be so less on the negative side. So this is a notation. And sometimes, whenever we are talking about real numbers, we can represent real numbers like this also. Sometimes we write real numbers like this. We write real numbers like this. So minus infinity to plus infinity. So real number include all possible numbers, which can be from minus infinity to plus infinity. Anything can come in between. So this is also a notation for writing real numbers. We use R also. We use symbol R for representing real numbers. Sometimes you can use this interval also to represent real numbers. Okay. So this is also a notation. So whenever infinity comes, it's unbounded. Exactly. There is no bound. There is no limit. Either it could be, so there is no limit on positive side, then you use infinity. There is no limit on the negative side, it's minus infinity. Yes. So whenever we have infinity, it is unbounded. Absolutely correct. Is that all right? So fine. So far so good.
Yes, ma'am.
ठीक है, चलो. तो हमने इंटरवल्स का बेसिक समझ लिया कि क्या क्या होते हैं, व्हाट दे आर. ओपन इंटरवल, क्लोज इंटरवल, बाउंडेड, अनबाउंडेड, इन्फिनिटी, माइनस इन्फिनिटी, रियल नंबर्स. All that we've understood. Okay, what is another concept which we will keep seeing and which we will keep repeating again and again? That is called absolute values. What is absolute value? We want to understand that. So right now we are all, jumping very, very quickly with whatever concept that will keep coming up. So that's why this is an introduction. Okay, so let's try and understand what is absolute values. So at any point, if you feel I'm going fast, let me know. Okay, all right. And at any point, if you feel I'm going slow, let me know that also. Absolute value. So what is an absolute value? Let's define that. So let A be a real number. So A is a real number. And imagine its position on the number line. So A is any real number. It could be any number, okay? And just try to imagine what position it is at on the number line. So now, this is the number line. At the center, we have 0, 1, 2, 3. It'll keep going on the positive side. And whenever you put this arrow, this means that it'll keep going on. Whenever you put a dot like this, if you put a dot like this, it means this is fixed. So let's say I put 10 here. So this line ends at 10. So it become a line segment, right? Line segment and line. Line doesn't stop, line segment stops. So whenever I write this arrow, it means it'll keep going on. And whenever I write like this, it means it'll keep going on the negative side. So -1, -2, -3, and then it'll keep going on. Okay. So what they're trying to say is whenever you want to understand absolute value, just think of any real number and imagine its position on the number line. So let's say our number is somewhere here. This is the number A. So now what you have to do is, whatever is the distance between this number and this origin or number 0, that distance is called the absolute value. Okay. So whatever this number is A, and whatever is its distance from 0, so 0 to A, whatever is the distance, it is called the absolute value. So your A could be here also, right? So whatever is the distance from 0 to A here, that would be the absolute value of A. So whatever is the distance, yeah. So the distance between A and 0 is called the absolute value of A. And how do we represent it? So the symbol to represent the absolute value of A is denoted by this. And what does this mean? So you see, whenever a number is lying on the right side of A, whenever a number is lying on this side, which is the right side of A, whatever is the number is actually the distance, yes or no? Right? So whenever my number A is on the right side of 0, that means it's a positive number. This distance is exactly whatever my number is. So that means whenever A is positive, whatever is the value of A is my absolute value. And whenever my number is on this side, this number is negative, but the distance will only be positive. Distance cannot be negative, right? Either you move this side or that side. So that is why if A is less than 0, this distance is actually negative of your number. So A is less than 0, meaning A could be -1. So what is the distance from 0 to -1? It's actually 1. So minus of -1 you have done. So negative become positive. So you are just trying to find out the distance from 0 to that number. It could be positive or negative. Okay. Distance is always positive. The number could be anything. All right. So this is how you would define your absolute value. So absolute value has a reason to exist. It tells you the distance from origin to the number. Okay. So this is the definition of this function. All right. So like if I have to find what is the absolute value of 3, it's 3. If I have to find what is the absolute value of -5, it's 5. If I have to find the absolute value of 0, what is this? 0. The distance of 0 from 0 is 0, right? There's no, you don't have to move at all. So it's 0. Is that all right?
Yes, ma'am.
Fine. Okay. All right. So now if I ask you a question, how to write absolute value of x minus 2 using the above definition. So my goal is to write the absolute value of x minus 2 exactly in the way that I've written this definition. So जैसे मैंने ये definition लिखी है ऐसे ही लिखना है. So what will we do? What is the absolute value of x minus 2? How will I?
Ma'am, it would be x minus 2 if x is greater than or equal to 2.
Very nice.
And it is 2 minus x if x is less than 2.
Very nice. So what we have written here, so jo bhi, whatever we had inside, it's exactly like that whenever this inside value is greater than equal to 0. So it's actually me saying that this value is exactly this whenever my x minus 2 is greater than equal to 0. And whenever this x minus 2 value is less than 0, this value will become negative. And the other way to write this very easily, when is x minus 2 greater than equal to 0? Whenever x is greater than equal to 2, which you have rightly said. So it's actually like this. So this is x minus 2 whenever x is greater than equal to 2, because this essentially is this only, right? And this is 2 minus x whenever x is less than 2. Is that all right?
Yes.
Okay. Okay. All right. So that is one thing. Now, if you are given two numbers, so if I give you something like this, there's a number x1 and then there is a number x2, and I am taking a difference of these two. So what will this tell me? This will tell me what is the distance between x1 and x2 on the number line. So if you have two numbers, 1 and 3, let's say. So let's say I have two numbers. So 0, 1, 3. If this number is 1, this number is 3. So one number is this, one number is this. So what will 1 minus 3 tell me? It will tell me whatever is the distance between these two numbers. So the distance between these two numbers is 2, right? So 1 minus 3 absolute value will tell me 2 only. My number could be here, 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 anywhere. If you take the difference between two numbers and take the absolute value, it will tell you what is the distance between those two numbers on the number line. Is that all right?
Yes, ma'am.
Okay. All right. What else? Is there anything else that we need to know? Okay. So let's say if I write that this mod of x value, you call it mod of x also, and we can also call it absolute value. Modulus. We call it modulus also, and we can also call it the absolute value. Later on, you'll see this is a modulus function, mod. So that is also the term that we keep using again and again, mod of x or absolute value of x, modulus or absolute value. Okay. So if I tell you that this absolute value is less than 2, so what does that mean? So we have to think about what all possible values x can take. Okay. This we have to figure out. So if my absolute value of x is less than 2, what all possible values my x can take? So whenever we are saying that the mod value, the absolute value of x is less than 2, what we are saying that whatever numbers have a distance from 0 to whatever number that is, whatever that distance is, if that distance is less than 2, that should be a part of this, right?
Yes.
If this is 0, this is 2, this is 3, and this is minus 2, this is minus 3. So which numbers should I be looking at? What are those numbers whose distance from origin is less than 2? This is what this statement means, right? That your distance from the origin is less than 2. So what are those numbers? So if I pick a number which is something like this, if I pick a number here, let's say 2.5. If I take a distance from origin, will that be less than 2 or greater than 2?
Oh, ma'am, it will be greater than 2.
It will be greater than 2. So that number should not be included here, right? Similarly, yes, any number which is lying to the left side of minus 2, that distance is not less than 2. Any number which is lying to the right of this point, that distance is also not 2. So which points are we sticking to? We are only sticking to these points because these are the only points at which the distance from the origin is less than 2, right? So which points are we talking about? X should be less than 2 and it should be greater than minus 2. Yes or no? Right?
Yes, ma'am.
So whenever you write this, or any combination is written, it just means that you are only talking about x values which are between this number and the negative of this number. So anybody, if they say something like this, that mod of x is less than a, This means that x values that you're talking about are lying from a to, so minus a to a, these values are lying. If they would have written this, we would have just included these numbers. Is that all right?
Yes, ma'am. Will there be a sign of included or not?
So if they give you equal, you include.
Yes.
If they don't give you equal, they are not included.
Okay.
Okay. So that means distance can be 2 also. So distance from origin to 2 is 2. Distance from origin to minus 2 is also 2. So you will include that if the distance is also equal to a. Okay. So you can write it like this. So distance. So this means x value is from minus a to a. And if they write it like this just means it's the same thing, except now you include it. All right. Fine.
Yes.
Okay. Now let's imagine the other thing. What if they say that the distance is greater than 2? Then which points are we talking about? So if they say something like this, that mod of x is greater than 2. So that means either my values are here, because then distance is greater than 2, or my values are here, because then also distance is greater than 2, right?
Ma'am, I have a doubt. If we go from the leftward side of -2, how will it be greater than 2?
Okay. So pick any value of your choice. Pick -4, okay?
Okay.
-4 to 0. What is the distance?
4.
4. Is that greater than 2?
Yes, ma'am.
So that logic.
Yes.
Okay. So even if you pick any value which is this side, because whatever number is, that negative will become positive, no?
Yes.
And yahan pe bhi whatever the number is, that same number is your distance. So whenever they say that this distance is greater than 2, you include these numbers also and these numbers also. So how can I write it? That my x value, this, what does this mean? That either x is greater than 2 or x is what? What should I write? X is, should I write greater or less?
Less than 2.
Less than -2, right?
Yes, ma'am. Mine.
So either these values where x is less than -2 or these values where x is greater than 2. Okay. So if somebody gives you this, that means you can write it like this: x greater than a or x is less than minus a. And if they put an equal, you just put equal everywhere. So if they give you something like this, you have to write this. Okay. Is that fine?
Yes.
All right. Narmada, is that okay?
Yes, ma'am.
Okay, ji. Chalo. Let's do one problem now. So these are the only two things which can complicate things for you, because I mean, we are not used to writing it like this, but if you understand everything in terms of distance, it makes sense. So if it's greater than a, then also distance is greater than a. If it's less than minus a, then also distance is greater than a. So just keep these things in mind. Okay. So these two will be very, very important for you. This and this. I mean, equality, not equality, that is exactly the same. All right. So if I have to ask you one question, find all the x values such that the distance from 3x minus 2 is less than equal to 5. So you have to find all those x values such that the distance of 3x minus 2 is less than equal to 5. This is your question. So how are we going to proceed? What should I do? Do I know something about this? How do I write this? How can I write this? X is between what? Minus a and a, right? Follow the same logic. Follow the same logic. Just assume this is not 3x minus 2. This is the big X only. So what will you do? You can write it like this. That 3x minus 2, it's less than 5 and this is greater than minus 5. You can write it like this. Following the same steps here.
Yes.
Now what you do? Now what you can do is you can add 2 on both sides. You can add here and here. When you add the same number in an inequality, it remains the same, right? So if you add 2 on all 3 sides, what are you going to get? Or you can, if you don't want to do that, you can do this also. So here, from here, you have 2 possible things. That 3x minus 2 is less than equal to 5 and 3x minus 2 is greater than equal to minus 5, right? These 2 things are there.
Yes, ma'am.
So this should be holding and this should also be holding. So you keep it separately and then try to figure out what it is. So okay, so these are the 2 things that we have. Now 3x, I can put it this side. So it'll become positive. 3x is less than equal to 5 plus 2 is 7. And x is less than equal to 7 by 3, right? This is okay.
Yes, ma'am.
Why? Because you can add or subtract, inequality will not change. You can divide and multiply with a positive number, inequality will not change. If you divide and multiply with a negative number, things will change. This was a positive number. We divided both sides by 3. That is a positive number. So nothing happened. Okay. Similarly, now what happens here? So what happens here? 3x, we put minus 2 on the other side. We get minus 5 plus 2 minus 3. I will divide both sides by 3. It is a positive division. I mean, division by a positive number that we are doing. So nothing happens to the inequality. It remains the same. So x is greater than equal to minus 1. So here what are we saying? That x should be greater than minus 1 and it should be less than 7 by 3. Both these things should hold. So how can I write it? That x should be less than equal to 7 by 3 and it should be greater than minus 1, right? So if my x value is greater than minus 1 and it is less than 7 by 3, this particular value, this absolute value will be less than equal to 5. Is that all right? So we can write it in closed interval also, right? Yes, absolutely. अब आप ये जो नंबर है ये आपके पास a आ गया और ये आपके पास b आ गया और दोनों included हैं. So you can write that x belongs to minus 1 to 7 by 3. This symbol means this symbol, ये जो symbol होता है इसका मतलब होता है belongs to. So x belongs to this interval. X is a part of this interval. Matlab x can take values in this interval. So yes, you can write it like this. Absolutely yes. A big yes. Okay. Is that fine?
Yes, ma'am.
Okay. All right. Okay, G. So, all right. Guys, let's do one thing. It's 1 hour. So let's take a 10 minutes break and we will resume after 10 minutes. And we will talk a bit about inequalities. And after that, we will do a lot of problems, right? Because actually problems are where people get stuck a lot. Okay. So we will understand few basic things related to inequalities and then we will do a lot of problems. So it's 7:02 right now. we will meet again at 7:12. So I'll be here only, but we'll resume in 10 minutes. So you guys can have some water, move around, and we'll join back in 10 minutes. All right. I'll see you in 10 minutes. Okay. All right. So we understood everything related to intervals and absolute values. So now let's start talking about inequalities, because वो भी बार-बार जो है they will keep coming and they will keep coming and haunting us again and again. So let's just try to understand them. Okay, fine. Let's see. So we also want to understand regarding inequalities. Okay, all right. Fine. So first thing that we have to understand is, if we have a number A, so so what we are going to learn now, some basic rules which we will apply to inequalities and which we can also apply while solving everything. So like this particular problem that we were solving, we were using inequalities without actually knowing, because we keep doing it and we kind of internalized it, but now it's time for making all those rules very, very clear. So first thing, if you have a number A which is positive, which is greater than 0, and you have a number B which is greater than 0, okay, and if you add these two numbers, so if A is greater than 0 and B is greater than 0, what does this imply? What does this mean? This imply that A plus B is positive, that is also greater than 0, and A multiplied by B will also be greater than 0. Okay, so this is simple. We know that. Second thing that we have is, if A is greater than B. So if we have a number A which is greater than B, and if we subtract these two numbers, A is greater than B, means that A minus B, if we subtract A with B, what are we going to get? We're going to get a positive number, right? Okay. What else? If A is greater than equal to B, and if we do the subtraction, then again, it's the same thing. But the only thing which will happen is, instead of greater than 0, it could also be equal to 0. A minus B is greater than equal to 0. Okay. Are we good so far? Are we able to imagine it?
Yes, ma'am.
Okay. Okay. Moving on. Other rules. All right. So if you have a number, so if you have this, A is greater than B, okay, and C is any arbitrary number. So what does arbitrary means? So it could be any number. It could be positive, it could be negative, it could be anything. So it's just that we don't know what C is, but C is just a number, okay? So if A is greater than B and C is any number that you have, then A plus C will also be greater than B plus C. So it's like, what are we saying? If A is greater than B and C is any number, it could be positive, negative, we have not put any restriction on that. If you just add those numbers, A plus C and B plus C, this inequality will still hold. Okay, that is what we are trying to say here. So this is what we used here also. So I was saying, no, please add 2 on both sides. It will remain the same. So that this property is what we were using. Okay. So if A is greater than B, and if you add the same numbers on both sides, this inequality will remain the same. All right. So for example, if somebody says find the values of X, which satisfy this. 2x minus 5 is greater than x minus 3. If somebody says find the value of x which satisfies this inequality, so what can you do? Can I add both side 5? Will the inequality still remain the same? Because this is some number, this is also some number, and I can add any number here. Won't make a difference. Just this property we can use, right? So
Yes, ma'am.
I can add 5 on both sides. So what do I get here? 2x minus 5 plus 5 greater than x minus 3 plus 5. So what do we get here? 2x greater than x plus 2. Okay. I can add something. So I can also subtract something, right? Can I subtract x on both sides? I can. Same logic. So 2x minus x greater than x plus 2 minus x. What will I get here? I will get x greater than x and x get cancelled and I will have 2. Right? So all possible values of x which satisfy this are greater than 2. Right? So what are those values which satisfy this? Any value of x which is greater than 2. Right? This is okay?
Yes.
Yes,
So
ma'am.
now I'm showing you every single step, like add those. And what we typically do is you can take it on this side, you can bring it this side. So all of that is actually, we are quickly doing the same things only, right? So we could have done that only. So those steps are coming from here only. It's just that when we start doing it regularly, we don't want to write all these intermediate steps. So that is why we say, okay, bring it this side, bring it this side. So that means that only. Okay. So we are trying to eliminate those things. All right. Okay. Moving on. What is the next rule that we have? So, if somebody says A is greater than B, and they also say that B is greater than C. So what can I say about A and C? What is the relationship that they will have? What is this?
Is greater than C.
Perfect. So that means this implies A is greater than C. So whatever I'm doing here with, greater than, it's equally applicable for greater than equal to also. Okay. So you can just keep that in mind. All right. What else we have here? The next property that we have is if A is greater than B, if A is greater than B, and if I have a number C which is greater than 0. So basically I have a number C which is positive. And if I multiply that number on both sides, so if I do this, AC, BC, so this inequality will hold. So what am I saying? If you are given A is greater than B, and you multiply both sides by a positive number, this inequality will remain the same. So it was greater, then it will remain greater. Okay. So like if you have 2 greater than 1, if I multiply both sides by 2, I will get here 4 and I'll get here 2. So still I know that 4 is greater than 2. Okay. But if I do a negative, will that still hold? So like if I multiply both sides by -1, what am I going to get? -2 and -1. Which one is bigger?
-1.
So inequality changes sign if you multiply by a negative number. So that is our next result. So what are we saying? If you know that A is greater than B and you have a number C which is less than 0, means it is negative, then this means that if you multiply both sides by C, you are going to flip your inequality. So this is very important always to be kept in mind. Always. That if you have an inequality and if you multiply by a negative number, your inequality will change signs. Students make a lot of mistake here. So please be very, very careful with this. Okay. that the sign are reversed if you multiply by a negative number. All right. So we will keep that in mind. All right. What else? So if we have something like this, that if A is greater than B, and we also know that C is greater than D, okay, then if you add this side and this side, and if you add this side and this side together, the inequality will remain the same. So A plus C will be greater than B plus D. This will hold. All right. This is fine.
Yes.
Okay, G. So we have a few. So basically these were simple, that, sum of two positive numbers and product of two positive number is positive. If A is greater than B, the difference is positive. If A is greater than equal to B, difference is positive. This is again important, that if A is greater than B and if you multiply by a positive number, the inequality will remain the same. Okay, that was different. That was Nietzsche. Yeah, that was this one. Here we simply mean that we can add any number on both sides. It could be positive or negative. The inequality will still remain the same. Okay. And yeah, if you multiply this, we also saw, if you multiply by a positive number on both sides, inequality remains the same. If you multiply by a negative number, the sign will flip. And if you have these inequalities and if you add them together, then this inequality will remain. Okay. So that is one. All right. Okay. Apart from that, there is something called double inequalities also. So we saw inequality. Sometimes we see double inequalities also. Two inequalities written at the same time. So what does that mean? Guys, are you able to hear some background noises? Is this okay?
Oh, yes, ma'am.
You are able, okay. There are some festivities going on. I don't know. People are blasting crackers. I don't know where. What is the situation? But fine. Okay. So what is double inequality? Double inequality simply means that when you have two inequalities that have to be satisfied at the same time. So if two inequalities have to be satisfied, if two inequalities are valid simultaneously, then we write double inequalities. What does that mean? That simply means this. What? So, if somebody says that A is less than equal to Z and Z is less than B, these two inequalities you've written. So if I have to write it in a single inequality, then how can I write? I know that Z has to be greater than equal to A, and I know that Z has to be less than B. So I will write it like this. Okay, so that is basically writing double inequality. All right. So if somebody says A is less than equal to Z and Z is greater than B. Okay. Then what should we do? Tell me. This is a question for you now. So if somebody says that Z is greater than equal to A, sorry, Z, yeah, here we are saying that Z is greater than equal to A, and here we are saying Z is greater than B. And they have to be satisfied at the same time. Now, how can I write it? Should I write it like this? That, Z is greater than equal to A, and should I write it like this? Or no? Or can I write it like this? Okay, so one way was this. We don't know if it's correct or not. Or should I write it like this? like A is, okay, can I write it like this? That Z is less than B, and okay, basically, can we write it like this? Or can we write it like this? What should we do? Which one is correct?
Ma'am, the first one is not defined and the other two are incorrect.
Right. And why? So we still have lots of examples which will invalidate it, right? So exactly. So we neither we can write it like this, nor like this, nor like this. Here, what are we saying? Z value is greater than equal to A value. Here we are saying Z value is greater than B value. I don't know what A and B are, right? Because here you see, let's say, if we see on number line, let's say this is A and let's say this is B. Let's say B is less. Okay. So then we are saying Z is greater than equal to A. So Z is greater than equal to A means this area. And Z is greater than B. So that means we are talking about this area. And both of them have to be satisfied. Then what is my common area? This. So that will be Z is greater than equal to A only, right? Yes or no?
Okay.
Right. And what if this would have been the case that actually B was not here, B was actually here? That could have happened, right? I just don't know what is the relationship between A and B. Then we should have this also. So what is the common area? Common area is this. So here we would have had this, that Z is greater than greater than B. So we don't know. Unless we know what is the relationship between A and B, we cannot say anything. So don't go by flow and start writing it like this. Okay, be a little careful about what is A, what is B. Here we don't know what is the relationship between A and B. Okay. So here they just said this. Okay. Is that fine?
Yes, ma'am.
Okay, perfect. All right. So, guys, these were some basic things that you have to keep in mind regarding inequalities, intervals, the absolute value or anything. Now, what we will be doing is we will combine all of these things and try to figure out different things. So now basic stuff is clear. Now you have to do more and more practice of questions. So let's try to do some problems here. Okay. So for example, so let's say this is the question that we have. What is the question? This is the question. Okay. So what is the question? Question is saying this, that x minus 1 times 3 minus x, this entire multiplication is greater than 0. Okay. And what you have to do? You have to find all possible values of x which will satisfy this. So you have to find those values of x such that when you put that in this inequality, it turns out to be positive. This is your goal. Are we clear with our goal? Right?
Yes, ma'am.
So whenever you face any problem like this, wherever, there are multiple things multiplied, or, they could have divided it by something also. So it doesn't matter. Do the following. First, what you have to do is try to figure out these things, this and whatever other things that are given. Try to find out when are they positive, when are they negative. Okay. Make a number line and try to figure out when is something positive, when is something negative. Okay. All right. So first we have to do what? We have to figure out when is something positive, when is something negative. Okay. So this is a number line. Okay. And here this is 0, 1, 2, 3, minus 1, minus 2, minus 3. Okay. All right. Can you tell me that, let's see if I talk about this. So first I'm talking about this, x minus 1. Okay. So what happens is, just, what you do whenever you face any such inequality, you just try to put these values equal to 0. So if you put x minus 1 equals to 0, what do you get? X equals to 1, right? And when you put 3 minus x equals to 0, what do you get as the value of x? 3. Yes.
Yes.
So we have two values of x, which will make it 0. Now what you have to do? Just try to see that I have x value 1 and I have x value 3. Okay. Just put these numbers here in the number line and see in how many regions is this getting divided. So x value 1 and x value 3. Now your number line is divided into how many areas? One area is this, one area is this, and one area is this. So there are 3 possible areas, right? 3 possible areas.
Yes.
What you do is just write those 3 areas. Okay. Okay. So what are my areas? So first is minus infinity to 1. Don't include 1. Okay. All right. What is the next area? 1, 2, 3. Right. And what is the other area? 3 to infinity. Okay. These are 3 regions in which my entire number line is divided. Okay. Now what you have to do is you have to see how each of these values is behaving in different intervals. So how is x minus 1 behaving in each region, and how is 3 minus x behaving in each region? Okay. So we have x minus 1 here and we have 3 minus x here. Okay. So can you tell me, whenever x value is less than 1, will this be positive or negative?
Negative.
It will be negative. So simply you can write negative here. What happens in this region? If x,
Positive.
it will be positive. So you can just write positive here. And what happens here?
Positive.
Again, positive. So just put positive here. Okay. All right. Fine. Now we do the same thing here. So if you put a number from 1 till minus infinity, so like minus infinity till 1, what is this? This is positive or negative?
Positive.
It will be positive. You can just pick one value and it will show you. Okay, so here it will be positive. Okay, what happens here?
Ma'am, this will also be positive.
This will also be positive. And what happens on this side?
Negative, ma'am.
This will be negative. So I know the behavior of these small factors in the 3 regions that I have, right? So my goal is very simple now. What do I have to do? I have to check whether this product is positive or not, right? Okay, whether this product is positive or not. So I have 3 regions, and individually in these 3 regions, I can check what is this product doing. So if you multiply 2 things and one is positive and one is negative, then the product is negative. And if both positive or both negative, it will be positive. So that we have to keep in mind. So what happens to this now? So x minus 1 times 3 minus x. In this region, one is negative, one is positive. So what will be the product?
Negative.
Negative. So you can put negative here. Similarly, what happens here? Both are positive. Now what do you do? Positive.
Yes, ma'am.
So this will be positive. And now what happens here?
Ma'am, it will be negative.
It will be negative. And what do I have to find? मुझे क्या निकालना है? Which numbers am I looking for? Where this product is positive? Right? So where is this product positive? 1, 2, 3.
Yes, ma'am.
Right? I will not count this. Not count this. I will only think about this. Okay. All right. One more question for you. Should I include 1 and 3 in this?
No, ma'am.
Because if I include 1 here, this will be 0, right? 0 is not greater than 0, right? Similarly, if I include 3 here, again it is 0. 0 is greater than 0. That's not true. So what are the only possible numbers where this is getting satisfied? From 1 to 3, right? So what are those x values? So x belongs to 1 to 3. This is your answer. Okay.
Ma'am, could we solve this problem by multiplying both the equations?
Multiplying.
The quadratic equation, then solving it.
Okay. How will we solve it? Chalo, let's do what you are saying. Okay. क्या करना है हमें बताओ.
और मैम जैसे इसमें x -1 और 3 -x को मल्टीप्लाई कर दे अगर तो
ठीक है.
3x.
इसको कर दिया मल्टीप्लाई. फिर उससे क्या होगा? 3x minus x square minus 3 plus x greater than 0, right?
Yes, ma'am.
So minus x square plus 4x minus 3 is greater than 0. Now, what should I do?
मैम आफ्टर दैट जैसे दोनों तरफ +3 कर दे और ऐसे आगे कुछ इसको इक्वेशन को सॉल्व करके.
इसको इक्वेशन को सॉल्व तो जब अगर आप इक्वल टू 0 करोगे तो x की वैल्यू 1 और 3 आएगी, है ना?
यस.
फिर उसके बाद हम लोग क्या करेंगे?
ओके.
यू कांट रियली सॉल्व इट, राइट? उसको आपको बेसिक फैक्टर्स में ही कन्वर्ट करना पड़ेगा.
ओके.
Okay. All right. Okay. Perfect. Okay. So you can do any such problem now? You're able to do it now?
Yes, ma'am.
Chalo ji. Let's do one more example. And let's try to see what needs to be done there. That one is a little similar to this only, but a little different. Okay, so we have another question. And it says, find the solution set of this. Whenever somebody says find the solution set, what does that mean? That means you have to find all possible values which satisfy this. That's the only thing. Yes, we will take up just after this, we'll take some related to mod also. Don't worry. Okay. All right. So something like this. Okay. Chalo ji. Perfect. Let's do this. Okay. So we have to find all possible values of P such that this equation is satisfied. So the first thing that you try to do is we have to apply similar method only. So we have to try to see that how can I bring 0 on one side and rest everything on the other side. Okay. So what you have to do is, if this is greater than this, can I do this minus this and that will be greater than 0? We've seen that as one of the properties, right? Can I write it like this? 2p minus 3 divided by p minus 1 minus 3 minus p, that is greater than 0. Right? So far, so good.
Yes, ma'am.
Okay. Now what you have to do? Just take the LCM. Let's see what happens. 2p minus 3. If you take LCM, you will get p minus 1. So you have to do here what? 3 minus p times p minus 1. And this is greater than 0. Okay. All right, let's try to solve it further. Now what happens? 2p minus 3 minus, this is 3p minus 3 minus p square plus p, right? And then this divided by p minus 1, and this should be greater than 0. Okay? Are we good with this? Okay.
Yes.
Now you just simplify it. 2p minus 3 minus 3p plus 3 plus p square minus p. Okay. And that entire thing divided by p minus 1, this is greater than 0. Okay. All right. Let's see what we can cancel here. I can cancel. So this is p and 2p and minus 3p. I get minus p and minus p. So I have minus 2p here, and I have minus 3 and plus 3. They get cancelled. And I have p square here. Okay. So p square minus 2p divided by p minus 1. And this should be greater than 0. Right? Now, what we can do is we can write it like this: p times p minus 2 and then divided by p minus 1, which is greater than 0. Right? Are we okay so far?
Yes, ma'am.
Okay. Now, it's a similar problem. Now, just try to put everything equal to 0. When you have factorized it like this, no? Now just put everything equal to 0 and try to find out what are the different regions in which your number line can be divided. So one value of p is 0, one value of p is 2, one value of p is 1, right? So now put everything on the number line and see. 0, 1, 2, 3, minus 1. So one number is here, one number is here, one number is here. How many regions we have now? Multiple region. One. So one is this entire region, then one is this, then one is this, and then one is this. So I have 4 regions now, right?
Yes.
I'll do the same thing that we did over there. So आपको same चीज करनी है. So minus infinity to 0, then 0 to 1, then 1 to 2, then 2 to infinity. Okay, that's what you have to do. So these are the 4 regions in which you have divided everything. Now you see the behavior of 3 possible points. And what are they? So I have here p, and I have p minus 2, and I have p minus 1. Okay. So p is positive where? In the first portion, will it be negative or positive?
Oh, ma'am, it will be negative.
Negative. Rest everywhere?
Positive.
Positive, positive. Right? Okay, fine. What about this? It will be
Ma'am, negative.
negative here.
Oh,
Negative,
yes, ma'am.
negative here.
And yes.
Positive here, right? Fine. What about the one value? Negative here, negative here, and positive in the next two, right?
Yes.
Okay, perfect. What do I have to find out? I have to make sure that this entire multiplication is positive. Okay. So if two numbers are positive, like if all 3 numbers are negative, then what happens? 2 will get multiplied and make positive, and then 1 is negative. So what is the final result?
Ma'am, negative.
Final result is negative. So we have a negative value here. What about this?
Positive, negative, negative. Oh, ma'am, it will be positive.
Perfect. So this is positive, and this is negative, and this is negative. So negative, negative become, they get cancelled. So they become positive. So here we have positive. Okay. What about this now?
Negative.
Negative. And what about all positive?
Positive.
All positive is positive. So this is positive. Which numbers am I looking for? I'm looking for numbers where this entire thing is positive. So what are those points? First is this and then it is this, right? So what are those x value? P values? P value should be from 1 to 0. And P value should be, not and, or. Either it is this or it is this, right? So P belongs to 0 to 1 and 2 to infinity. And because we are okay with both these, so we will just put union. Union is when you want to combine those numbers. Okay. Is that fine?
Yes, ma'am.
So this is the solution. This is the solution. So these are all those points which will satisfy your particular condition. ठीक है जी, clear है ये?
Yes, ma'am.
चलो अब एक दो एग्जांपल्स और करते हैं रिलेटेड टू इनइक्वालिटी. फाइन. चलो जी, लेट्स डू दैट. ओके, लेट्स सी. So yes, fine. Okay, so let's say I have something like this. So let's say somebody asks me that solve this. Mod of x is greater than equal to root 2. What does that mean? How can I write? So everybody, in every question, it is being asked that I have to solve for what possible values of x will satisfy this. So this is a clear application of something that we studied. How can I write this? X should be greater than equal to what? I'm saying distance is greater than root 2. So which possible values I'm looking at?
Root.
Yes or no?
Yes, ma'am.
Right? So either, so x belongs to minus infinity to root 2. And because it's equal to, so you can write it like this. Union root 2 to infinity. Right? That is fine.
Yes, ma'am.
Okay, fine. Next, other thing that we could have is related to absolute values only. Let's say somebody says solve this, that x square minus 2 times mod of x minus 3 equals to 0. Somebody says find the value of x. The values of x which satisfy this. So what will you do now? Okay, I have to solve this inequality, right? I have to solve this equation. Now, I know that absolute value of x is equals to x if x is greater than equal to 0, right? And it is minus x if x is less than 0, right? So what will you do now? You will consider cases. So first case will be if x is greater than equal to 0. So if x is greater than equal to 0, then how can I write this equation? How can I write this equation? If my x value is greater than equal to 0. How will I write it? So somebody told you from outside that x value is greater than equal to 0. Then
Ma'am, it will be x square minus 2x minus 3.
perfect. So x square minus 2x minus 3 equals to 0. Can I solve easily?
Yes, ma'am.
You can. How will you do x square? You have to make this in two parts. You have to make this sum into two parts such that the product is -3 and sum is -2. How will you do that? So you can do minus 3x plus x minus 3 equals to 0. Right?
Yes.
What will that bring? X common, you can take common, plus 1 x minus 3 equals to 0. You can take x minus 3 common. X minus 3, x plus 1 equals to 0. What is the possible values of x that you are getting? X is equals to 3 or x is equals to -1. Which value you will pick? Is this value allowed?
No, ma'am.
No, because your starting point was what? That x is positive. So this is rejected. Only this you can keep, right? So only this value is valid here. So one value of x that you got is x equals to 3. Fine. This is rejected, right? This is rejected. Now, what is the next thing that you will do? You will again do the other scenario where x is less than 0. So if x is less than 0, then what happens? Then how can you write this equation?
Oh, ma'am, it will be x square plus 2x minus 3 is equal to 0.
Perfect. X square plus 2x minus 3 equals to 0. Now I have to do the same thing. I have to factorize it such that sum is 2, product is -3. So I can do this. Right? What you can do, x plus 3 minus 1, x plus 3 equals to 0. You can take x plus 3 common. And you can have x minus 1 here. What are the possible values of x which will make it 0? Either x is equals to -3 or x equals to 1. Which value you have to take here?
X is equal to -3.
So this will be rejected. This will be rejected. And this you will keep, right? Because x is less than 0 here. This is rejected. So you solved this, and what are the two values that you got? X is equals to 3 or x is equals to -3. These are the two values which will make this equation valid. All right? Is that
Yes.
fine? Okay. Narmada, this is clear?
Yes, ma'am.
Okay, Ji. Perfect. Let's move on. Let's do one more. All right. Let's pick one more problem. Okay, so let's say you have a problem like this. So let's say somebody says, find the values of x such that x square minus 2, the mod of this is less than equal to 1. Okay, solve this. Fine, somebody gives you this. Then what happens? Chalo, tell me. What can we do now?
-1 less than or equal to x square minus 2 greater than or equal to 1.
Perfect. So x square minus 2. This particular value is either less than equal to 1 or it's greater than equal to -1, right? Yes. So far it's good. Now what you can do is you can add 2 both sides, like everywhere. What do you get? X square 3 1, right? ठीक है? Okay.
Yes.
So now you have two things. This is a double inequality, right? When do we write double inequality? When both these things have to be valid. So these two things have to be valid at the same time. Okay. So x square should also be less than equal to 3 and x square should also be greater than equal to 1. So these two things have to be valid at the same time. So what is the first inequality? That x square should be less than equal to 3. What is the second inequality? X square should be greater than equal to 1, right? When is x square greater than equal to 1? When x is greater than 1 or when x is less than -1, right? So what you can do is, you know, whenever you take a square of a negative number, that is also positive, right? Yes or no?
Yes, ma'am.
So, you know how you can deal with these. So x square, if somebody says x square is greater than equal to 1, what you can do is you can take square root on both sides. And when you take square root, you get this. Okay. Whenever you take square root, you will be getting only a mod value everywhere, right? Yeah. So I'm saying, okay, so far we've understood this, like till this point we are okay, till this and this.
Yes, ma'am.
Yes, ma'am.
Okay, now see, you tell me, if I'm taking x value to be -5, does this equation hold? -5 will, if you square it, it will become positive 25.
Yes.
Right? So even if you are taking values which are greater than 1, it'll hold. And even if you are taking values which are less than -1, this will still hold. Are we getting this? Right? So because you know this is x square, I can write x square as mod x square only. Right? Can we write it like this?
Ma'am, I have a doubt after this step. How can we write x square as mod x whole square?
Okay. So mod x is what? X if x is greater than equal to 0, right? And
Yes, ma'am.
minus x if x is less than equal to 0, right?
Yes, ma'am.
And if you do the square of it, अगर आप इसका स्क्वायर करोगे तो आपको इसका स्क्वायर करना पड़ेगा if x is greater than equal to 0,
Yes, ma'am.
which is x square.
Yes, ma'am.
And आपको इसका स्क्वायर करना पड़ेगा whenever x is less than equal to 0.
Yes, ma'am.
And minus x का स्क्वायर क्या होता है?
X square.
x square only, right? So
Yes.
जो x square है उसको आप mod x का स्क्वायर भी लिख सकते हो, क्योंकि चाहे x पॉजिटिव हो या नेगेटिव हो, mod x का स्क्वायर हमेशा x स्क्वायर ही होगा. Yes or no? So the only point that we are trying to make here is कि जब भी आप स्क्वायर के अंदर जब वैल्यूज देखते हो, ये बोथ पॉजिटिव और नेगेटिव हो सकती हैं. दैट्स द ओनली पॉइंट दैट वी आर मेकिंग, राइट? मेरी x की वैल्यू चाहे 5 हो तो भी मेरा आंसर वैलिड है, x की वैल्यू -5 हो तो भी मेरा आंसर वैलिड है यहाँ पे. Yes or no?
Yes, ma'am.
Right? So here we are just saying that. So all I'm saying is, if you take square root, whenever you take square root, you keep the mod value. So if you take square root on both sides, what happens is you can write it like this. So x square is greater than equal to 1. You can write it like mod of x is greater than equal to square root of 1. That's how you can write it. Similarly, you said x square is less than equal to 3. You can write it like this. Mod of x is less than equal to square root of 3. Right? This is a result, basically.
Okay.
Right? Why are we able to say this? Because even if we take positive values, then also this is valid. Even if we take negative values, it will still be valid, right? We have to consider that. So it's not like only when x values is greater than 1, then this will hold. For even negative values, this will hold, right? Yes or no?
Yes.
Okay. So whenever somebody writes this, that, x square is greater than equal to a. So what you can write is mod of x is greater than equal to square root of a. Okay. Because x square is basically mod of x square. You can write it like that also. Or you can say root of x square is basically mod of x. You can write it like this also. So whenever you take square root, you only want positive values to be coming out of it. Is that okay? Right?
Ma'am, I'm not able to understand the last step. That is, under root of x square is equal to mod of x.
Okay. So all we are trying to say is whenever you take square root, can something negative come out of a square root? So like if you take any number, square root of 100, can you ever say that this is minus 10?
No, ma'am.
You can't say that, right?
Yes.
But if you do 10 square, that is 100.
Yes,
But
ma'am.
if you do this also, this is also 100. Right?
Okay, ma'am, I got it.
Right? That's the point. Okay. This, because we are saying that this x can take positive and negative values, but whatever comes out of the square root will be positive. Okay. That's the only thing that we are claiming. So using these logics, what we can say here is first, x square is greater than equal to 1. So that means mod of x is greater than equal to square root of 1. And the other thing that we have is this. X square is less than equal to 3. So I can write it like taking square root on both sides. I can write it like this. Right? These are the two things that I have done. Are we okay with this?
Yes, ma'am.
Okay. Now you see what you can do. So x value, root 1 is 1 only. So x value is greater than 1 or x value is less than minus 1. Yes or no? This is simple inequality that we are opening.
Yes.
Right? And here what we are doing, x is between root 3 and minus root 3, right? Yes or no?
Yes.
And both these things should hold, right? Because we want both these things at the same time. So now what you do, just try to figure out what is the common area. So you plot this number line and see. So what are the numbers here? We have the following numbers. 1, we have 0, we have minus 1. Root 3, what is root 3's approximate value? 1.73 something. It's greater than 1 only, right? Root 3 is greater than 1? Yes?
Yes,
No?
ma'am.
Right? So somewhere, let's say this is root 3 value and somewhere this is minus root 3 value. So 1 values of x's that we are getting, what are these values? This is root 3 to minus root 3, right? What are the other set of values that we are getting? First is x greater than 1 or x less than minus 1, right? And we want both of them to be satisfied at the same time. So what do we do? This is open, this is open. This is closed. Closed means these values are included. So what is the common area? The common area is this. First is this common area, and then this is this common area, right? Yes?
Yes, ma'am.
So what you have to do is, so from here till here, and from here till here. And are these values included? No. So what are the values that you will be getting? So either x lies from minus root 3 to minus 1. Okay. Or x lies from 1 to root 3. Yes or no?
Yes, ma'am.
And that is the solution to my problem. Now if you take any value between here, no, this inequality will be satisfied, that your x square will be lying between 1 and 3. Rest everywhere you take any value, you will be getting something which is basically either less than 1 or greater than 3, right? So that is your solution. So what is your solution? X belongs to minus root 3 to minus 1 union 1 to root 3. That's what you have. Is that okay? So what was the important thing here? Just realizing that whenever you take a square root, there is a mod that is there. Okay. That was the only tricky point. After that, what you did? So first, we solved this absolute value using this inequality. Then we had two inequalities. We had a square. So we remembered that, okay, we have to use mod. Then we solved this and this at the same time because we wanted both of them to hold. X square should also be greater than 1 and x square should also be less than 3. So we had this and then this. And then we saw, okay, because we want both of them, we only look for the common region, right? So common was this and this. So here we saw, okay, because root 3 equal, so it's a closed dot. And because it's not equal, it's open. That means this value is not included. So your common region was this closed till this open till this closed. And this is the answer that we have. Is that fine?
Yes, ma'am.
Okay, Narmada, this is okay?
Yes, ma'am. Ma'am, the one which is written in green color pen, should it be and or?
This one?
Yes, ma'am. And is written there, right? So it should be
Yes.
or, right?
No, it should be and.
And.
Because we want x square to be greater than 1 and x square to be less than 3 also, right?
Okay, ma'am.
Because we want these two things at the same time, right? That's why we are writing and. So whenever
yes. In this slide, when it is written mod x is greater than or equal to root 1. So should we write as it x is less than equal to 1? Should there be a sign of
okay. Sorry. My bad. Yes. You're right. I don't know why I did not do that. Yes. Perfectly. Yes. You're right. Okay, so this will be closed only. Yeah. Okay. Done. So this is closed only. Yeah. My bad. Yes, absolutely right. Okay, because because this was equal, so we will have equal here only. Okay. That's correct. All right.
Yes.
Okay, G. All right. Okay, guys, I think let's stop here for today. It'll be too much if we keep continuing. So we'll do more problems, and in the next class that we have on Wednesday, we will do logics, necessary condition, sufficient condition, proposition, all of those things. And we will also talk a bit about proofs and then set theory. Okay. So that all those concepts along with lot more problems. Okay. So I'll see you guys on Wednesday for mathematics, and tomorrow 6 p.m. we have the statistics class. So yeah. Okay. All right. I hope you were able to understand everything. There was no problem at all. Or if there are problems, let me know. All okay?
Yes, ma'am.
Okay.
I understand.
Perfect. Okay. Okay, Anshika. Okay, Narmada. Thank you so much. Take care, guys. Have a good night. Thank you.
Thank you, ma'am.
Thank you, ma'am.
Bye-bye. Take care.